Ever wanted to create your own programming language, like a real chat dev? Well, guess what? It's stupidly easy. And no, we're not talking about building the next C compiler or writing an LLVM backend from scratch. That's actual pain, the kind of pain that makes grown devs cry and has you debugging assembly at 3 a.m. Instead, we're building a simple interpreted language using Java, and we'll do it with a tree walking interpreter. But wait, what even is a programming language? At its core, a programming language is just a fancy text that gets turned into instructions a machine can understand. There are two main ways to do this. First, we have compilers. So, compilers translate the entire code into machine instructions before running, like C compiler, Rust, or Go. And interpreters, they execute code line by line as they read it, like Python or JavaScript. So, today we're going with option 2, an interpreter, which means our program will read, understand, and execute code all at once, no extra steps. And the easiest way to build an interpreter, a tree walking approach. Think of it like this. First, we break code into tokens, words, numbers, or symbols. Then we parse those tokens into a tree structure known as an abstract syntax tree. And finally, we walk that tree and execute each operation. It's literally just a bunch of if statements and recursion. Sounds simple, right? That's because it is. By the end of this video, you'll have your own bootleg Python that nobody really asked for, but it looks good on your resume. So let's stop talking and start coding. So first, we need a lexer or a lexical scanner, or just a scanner for short, which takes raw text and turns it into tiny bite-sized tokens. This is the brain-dead simple version. Our lexer will read characters one by one and group them into tokens like numbers, operators, and keywords. This is the part where you define what keywords play what role. You can either reserve a syntax that people are already familiar with, or you can brainfuck your own little esoteric language just for the memes. Or even worse, use indentation instead of blocks and semicolons just to be different. Boom, lexer done. It's not perfect, but neither is JavaScript, and people still use that today. Now that we have tokens, we need a parser that turns our token soup into a syntax tree. A syntax tree is basically a fancy way of saying nested objects that represent operations. If that looks familiar, it might as well be from the deep pits of your CS class memory dump. Here's how we make it. Yes, it's just a bunch of objects. Now, time for our final boss, the actual interpreter. So this bad boy will walk the syntax tree and execute operations just like a calculator. Yes, that's it. We recursively evaluate the tree, crunch numbers, and boom, we have our own interpreter. Or really just a very weird calculator built by that one kid with ADHD in your class. And just like that, we have a fully functional programming language. Well, kinda. This is the bare bones version, but if you add variables, functions, and loops, you'll end up with our own full blown scripting language, just like the one I made here. PowerLink supports dynamic typing, first class functions, closures, and a set of built in functionalities that allow you to build applications quickly. I urge you to go ahead and write one of your own, and you'll come to terms with why JavaScript is really the way it is. So, what did we learn today? Writing an interpreter isn't that hard. Java is still verbose as hell, and you're now 5% closer to becoming a language designer and are fully eligible to add it to your resume. So go forth, create your own cursed programming language, and remember, if JavaScript can be popular, anything is possible.